won't believe what we've discovered. Let's start from the beginning. Hey everyone, this is Marketing Manager Reese Hurwitz, as well as Product Design and Developer Cameron Hurwitz, coming to you today from Magnum Bowling Products.
As most of us know, the bowling industry has hypothesized the causes of ball death and cracking for decades, but hasn't yet landed on anything concrete. At Magnum Bowling Products, we have spent the last 6 years researching, testing, and developing the tooling required to visualize and interpret the changes to a bowling ball over time. And thus, we have identified the contributing factors leading to coverstock deterioration and cracking. Reactive resin bowling ball coverstocks are designed and formulated to have specific hardnesses called durometer, which directly controls the on-lane performance and ball motion for today's synthetic lane conditions. Most manufacturers target a durometer range of between 73 and 75, which can easily be measured using a durometer gauge. It's also important to know that reactive resin coverstock formulations use softening agents, often referred to as plasticizers. Let's look at a ball that has never been thrown down a lane, and as you can see, when the durometer gauge pin penetrates the coverstock's surface, the plasticizer, which looks remarkably like lane oil, oozes out, which shows you that the coverstock is saturated with plasticizer straight from the factory. As you probably know, coverstocks are very porous, which is obvious given that the balls absorb lane oil. This is a result of the rapid catalyzation that occurs when the resin formulation cures, also known as cross-linking. This process creates heat, causing solvents to flash off and vaporize, leaving the bowling ball with a series of pores and microscopic air pockets all throughout the coverstock. The remaining plasticizers keep the ball at the factory fresh desired hardness. Unfortunately, they have a tendency to evaporate out over time and cause the ball to dry out. The loss of plasticizers leads to significant shrinkage, hardening of the coverstock, and a decrease in the size of the bowling ball's contact patch or footprint, which is responsible for lane engagement.
Another significant effect of coverstock shrinkage is that the pores become smaller. As the pores of the coverstock shrink, the ball loses its ability to absorb oil as quickly. This affects the ball's ability to plow through the lane oil. Here, we have two identical balls that were poured on the same day. The ball on the top screen was kept in a special enclosure designed to keep it the same way it came out of the mold at the factory, soft and supple with a durometer of 75. The ball on the bottom screen has been in the manufacturer's packaging for 9 months and has significantly dried out and hardened with a durometer of 79. You won't believe the comparison between these two balls and their ability to absorb oil. The softer ball's oil absorption rate is much faster than that of the harder ball. After 1 minute and 52 seconds, the softer ball has absorbed virtually all of the oil, even though it had been bowled with for several hundred games. Whereas the harder ball, that has only been thrown a few times, still had thick streaks of oil and is absorbing very slowly. It is very clear that the harder, dried out ball is still struggling to absorb the lane oil even after 10 minutes. So what does this mean to you as a bowler? The lack of oil absorption is proof that the coverstock has dried out, the durometer or hardness of the ball has increased, and the contact patch or footprint, which is responsible for lane engagement, has become smaller. Bowlers purchase specific bowling balls with the understanding that they will perform a certain way. With that being said, an arsenal of bowling balls is built to give the player a well-rounded and diverse selection of balls that can tackle any given pattern. Due to the significant loss of lane engagement over time, dried out balls aren't able to create friction in the front part of the lane like that of factory fresh balls, and in turn, they retain axis rotation longer and causes the ball to have a more angular and inconsistent reaction down lane. In order to maintain your arsenal and each ball's specific purpose, they must be protected from aging by immortalizers.
The patented Immortalizer is a dual-layer vapor barrier enclosure designed to maintain the factory-fresh performance of your bowling ball. The mylar material used in both the inner and outer layer of the Immortalizer is an effective vapor barrier and does not allow any of the bowling ball's softening agents to escape. Therefore, the plasticizers and other essential chemicals cannot evaporate out of the coverstock. Additionally, sandwiched between the two layers of mylar is a soft, flexible insulation designed to keep your bowling ball from experiencing thermal shock. Thermal shock is when your bowling ball encounters a rapid shift in temperature and cannot withstand the stress caused by the expansion or contraction of the ball's layered materials. This results in circumferential cracking. Included with every Immortalizer is our patented circulating air ring, which is designed to help combat circumferential cracking. The open design of the support ring allows room temperature air to flow freely beneath the ball. This counteracts the effect of a cold basement or garage floor and eliminates what is called polar temperature differential, which is what happens when the top of the ball is warmer than the bottom. This can create surface tension and stresses that sometimes result in spontaneous cracking. In essence, the patented circulating ring maintains a consistent temperature around the entire bowling ball. In order to properly use your Immortalizer, you open the bag and place your bowling ball inside. Next, you press both plastic strips together, fold over once and press down to release all of the air. Then fold over again and attach both Velcro tabs, making sure to cover the air bleeder holes. It's that simple. To sum it up, with the consistent use of the Immortalizer, you will be preserving your bowling ball's manufactured purpose. Not only that, but you no longer have to worry about going to grab your ball, only to find that it is cracked and no longer usable.
Hi everyone, I'm Scott Hurwitz, president and founder of Magnum since 1982. And I could personally tell you, we're very excited to be allocating company resources to this exciting new and innovative product, which we feel will have a great impact on the bowling world.
To prove the accuracy of our findings and the effectiveness of the Immortalizer, we've performed an experiment using a bowling robot for consistency. Let's head on over to our engineer Darsh, who will explain the experiment in cool engineering lingo.
Hey everyone! We conducted a 16-month study to determine what happens to bowling balls over time and if their physical characteristics change. Our experiment used 4 identical reactive resin bowling balls, which were all manufactured on the same day. All of these balls were chosen to have the same overall weight, top weight, and pin length. This way, these 4 balls would make reliable test subjects when comparing them to each other. Ball number 1 was placed inside an Immortalizer and stored at room temperature at all times. Ball number 2 was also placed in an Immortalizer but kept inside a test oven for 6 weeks at 120 degrees Fahrenheit. For the remaining 14.5 months, the ball was stored in the Immortalizer at room temperature. Ball number 3 was left in the manufacturer's original packaging and was always stored at room temperature. This packaging consists of a plastic bag and a cardboard box. Ball 4 was also placed in the test oven at 120 degrees Fahrenheit for a period of 6 weeks without any protective enclosure. It was then stored on a shelf in a ball cup at room temperature for the remaining 14.5 months. This experiment will directly compare the balls against each other to determine the effectiveness of preserving a bowling ball in our patented Immortalizer bag. It is common knowledge that high temperatures accelerate evaporation. In parts of the country, summertime temperatures can stay high for as long as 6 months, which we have mathematically converted to 6 weeks of oven time. Do bowling balls naturally dry out? Will heat cause a bowling ball to lose its plasticizers even more quickly? We measured and recorded data for all 4 balls before and after the experiment. We observed that the balls protected by the Immortalizer did not show any change in its features and characteristics. However, balls number 3 and 4, which were not protected by the Immortalizer, showed an increase in diameter and a reduction in overall weight, diameter, footprint, and on-lane coefficient of friction. We have now determined that the properties of these balls are not the same anymore.
Okay, now that our engineers have accumulated all the results and data from our years of testing, it's time to move on to the final phase of real-life, in-the-field testing using the mechanical robot. This will yield some powerful data, and I can't wait to see the comparisons and end results. So let's check it out.
Each of the 4 balls that were treated differently were all thrown with the exact same launch parameters using a bowling robot. It's important to note that all 4 balls were placed in the Storm Surface Factory machine to return the test subjects to their factory surface preparation of 2000 grit prior to the robot testing. In addition to the robot, we also utilized the SPECTO tracking system to accurately trace each ball's path and gather significant data points which proved to be extremely revealing. These 4 lane graphs are representative of each ball's on-lane performance. Taking a look at ball 1, which was stored in an Immortalizer at room temperature, you can see that the ball begins to create friction in the early portion of the lane and therefore demonstrates a very gradual and controlled transition from the PAP to the PSA. This results in the ball having a smooth and continuous motion through the lane, recovering all the way back to the pocket and driving through the pins. This ball performs as to be expected given the manufacturer's design intent. Ball 2 was stored in an immortalizer in a circulating oven. Similar to that of Ball 1, Ball 2 begins its hook in the front part of the lane and shows a gradual transition from the PAP to the PSA, therefore demonstrating a ball motion that is both smooth and controllable. As a result of the virtually identical reaction to that of Ball 1, Ball 2 consistently makes its way to the pocket and drives through the 1-3. Ball 2 exemplifies performance attributes in alignment with what is to be expected given the ball's manufacturer design intent. Ball 3 was stored in the factory packaging at room temperature. In contrast with Ball 1 and 2, Ball 3 did not read the front part of the lane and therefore had a quicker transition from the PAP to the PSA, thus making the ball more uncontrollable down lane. As you can see in the video, Ball 3 skidded further to the right than Balls 1 and 2 because it did not create the friction required to keep the ball from skidding further and further to the right at the breakpoint. As a result, Ball 3 struggled to hook and did not recover back to the pocket. With that being said, Ball 3 did not demonstrate a reaction that is to be expected given the manufacturer's design intent. Ball 4 was stored without any protection in a circulating oven. Ball 4 did not create much of any friction in the mid or front part of the lane and therefore skidded further to the right than all 3 previous balls. As a matter of fact, Ball 4 created such little friction that it could not grip the lane and resulted in a gutter ball. Of the many shots thrown, there were instances where the ball barely hung on and left washout splits. Given that, Ball 4 did not demonstrate a ball reaction that is to be expected given the manufacturer's design intent. Here is a representation of the 4 balls using SPECTO. In conclusion, when comparing the SPECTO data and looking at the response variables from each of the 4 balls, the difference is unbelievable. Even though the robot threw all of the bowling balls over the same line, you can begin to see the separation in paths at around 30 feet as a result of the unprotected, or in other words, unimmortalized balls lacking lane engagement and continuing to skid further to the right at the breakpoint. Looking at the data SPECTO provided, this can be seen through the vast difference in skid, breakpoint, and total hook.
I always thought my ball cracked because I left it stationary for too long, or maybe it was because I put it on a wooden ball rack, or even because it was getting too cold.
Yes, while those factors may contribute to the cracking of bowling balls, cracking is mainly a result of the drying out and hardening of cover stocks, the development of surface tension, thermal shock, and polar differential.
Bowling balls lose performance because they get too saturated with oil, right? As a matter of fact, I'm heading over to the pro shop now to get my bowling ball rejuvenated and oil extracted.
Actually, bowling balls lose their original performance because of the cover stock drying out, the durometer increasing, and the footprint getting smaller. And, about that rejuvenator, I wouldn't use that if I were you. They remove the plasticizer along with the lane oil and dry out your cover stock. Your ball will end up in worse condition than it was before rejuvenation.
All undrilled bowling balls will have perfect lane engagement and are still fresh, regardless of their age. On that note, I saw a nib discontinued bowling ball on Facebook Marketplace for only $300, and I think I'm going to buy it.
Believe it or not, bowling balls continue to age and harden even in the manufacturer's packaging. With that being said, I'd save my money if I were you. While that ball still may have its striking ability, it will not have the same ball motion attributes that it had when freshly manufactured.
My ball stopped absorbing oil and isn't hooking as much. I think it's because it's oversaturated with lane oil.
While that may seem like the case, a bowling ball stops absorbing oil because the cover stock shrinks as it dries out, and all of the microscopic pores responsible for soaking up the oil constrict and become smaller.
Well, it looks like most of the bowling balls in my arsenal are biting the dust. I guess I'm gonna have to go to the pro shop and spend $600 on a new set.
Do yourself a favor. Since you're buying a full new arsenal of bowling balls anyways, the timing couldn't be better. Make sure to get yourself immortalizers to go with those balls to preserve the life of your fresh purchase.
In closing, we've busted the myths that have been common knowledge over the last decade or two.
We've demonstrated undeniable evidence that as a ball dries out, either through natural evaporation or intentional removal, your ball will not perform according to the manufacturer's original design intent.
As avid bowlers ourselves, we know the value of a brand new factory fresh ball by the way it reacts in the lane. If you want to keep it that way, Immortalize your balls by visiting us at magnumbowlingproducts.com.